Chapter 4, Section 6 is on more triangle congruent stuff, but we're going to learn 3 new shortcuts. So by the end of this lesson, you should be able to apply these 3 new shortcuts to solve problems, and that you should be able to prove triangles are congruent by using these 3 new shortcuts. So what are they? Angle-side-angle congruence theorem says that if 2 angles and the included side of one triangle are congruent, so 2 angles and the included side of another, that the triangles have to be congruent. So the included side is like the side in between. So it's saying you have an angle, a side, and an angle. Angle, side, angle. And then angle, side, angle again. So it has to be in that order. If we have that, we know the 2 triangles are congruent. Next one is angle-angle side. So if 2 angles and a non-included side of one of the triangle are congruent to the corresponding angles and a non-included side of another triangle, then the triangles are congruent. So again, you want it to be in order. You have an angle, another angle, and then a side. An angle, and then a side. Then we know the whole triangle has to be congruent. And now this next one's kind of a weird one because it only works with right triangles. Hypotenuse and leg. And remember, your legs make the right angle, and your hypotenuse is across from the right angle. So if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the whole triangle has to be congruent. So we need a leg and a hypotenuse in order to do this, because we technically have an angle already here. But remember, this only works for right triangles. So we're going to do a couple problems where I'm just asking you, do you have enough information to prove that things are congruent? We're not actually going to prove them. So you're looking to see if it matches any of these 3 that we just talked about, angle, side, angle, 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 side, and hypotenuse, leg, plus the ones we did yesterday, the side, 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 and the side, angle, side. So we have all of those options. We have side, side, angle, side, angle, side, 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 hypotenuse, length, and angle, angle, side. Those are the only options we can use. So let's look at this first triangle here. I have an angle that's congruent to another angle, and a side right in between them, and then another angle. So can we prove that these are congruent? Yes, we're going to use angle, side, angle. So let's take a look at this one. We have an angle and a side, and then another side. An angle, a side, and another side. Unfortunately, ASS is not one of the theorems we get to use. If you have 2 sides and only 1 angle, it needs to be in between, like side, angle, side. So this one doesn't work. No, we do not have enough information. Now the next ones, we have 2 angles that are congruent. So angle and angle. We don't have any information about the sides. We can use the third angle theorem to say that these angles are also congruent, but there's no such thing as angle, 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 because a triangle could be dilated and the sides could change, even though the angles stay the same. So no, we do not have enough information to prove for this one. Now the next one is a right triangle. So when you notice that you have a right triangle, remember all you're looking for is, do you know the hypotenuses are congruent, which they are, and one of the legs, which they are. So yes, we can prove this by the hypotenuse length theorem. Next one, I have an angle, and a side. Or we could say a side, angle, angle. Now side, angle, angle, or you could write it angle, angle, side. That one works. That's one of the ones we just learned today. So yes, we can prove this. Now the next one, they only give us 2 pieces of information. They give us an angle and a side. An angle and a side. But then we know vertical angles are always congruent. So this angle here has to be congruent to this one here, which gives us another angle. So that means by angle, side, angle, we can prove that those 2 triangles are congruent. So now let's actually do some congruence proofs. So determine if I can use angle, side, angle to prove that these triangles are congruent. So we need an angle, a side in between them, and then another angle. Now right now they give us these two angles are congruent. We know that this line has to be congruent because it's the same in both triangles. We could use the reflexive property. And then another angle over here. So we have an angle, a side, and an angle. But they are not right in a row. In order to use angle, side, angle, they have to be all in a row. So we would need like this angle, this side, and then this angle. Or we'd need the angle that they give us, the side that they give us, and then this angle down here would have to be congruent. So no, we cannot prove that these triangles are congruent because the angle, side, and other angle are not in a row. And we're going to use adjacent as our fancy term for in a row. So you have to be careful. Even though you might have three pieces of information, if they're not in the right order, you can't say that they're congruent. So let's do a two-column proof. We're given some information here, and it's already kind of filled out for us. So let's write down our statements, and our reasons. So our first statement is that angle X has to be congruent to angle V. So it's this one here is congruent to that one there. And we can say that because it's given to us. Now that doesn't tell us any other information, so let's jump to the next given. We know that angle angle YZW is congruent to angle YWZ. YZW, so this one here is congruent to this one here. That's given. And then our next one, we have segment XY is congruent to segment VY. So just with the givens, do we have enough information to prove that these triangles are congruent? We want to prove that this triangle here is congruent to this triangle here. So we really don't care about the YZW. So sometimes it might help to rewrite things out, kind of get an idea of what we know. We have a side and an angle, and that's really it. The other piece of information that they gave us doesn't talk about the triangle that we're concerned with. So we know we have to use that somehow. So if we go back up to this big picture with all of them, this is a line. Even though they don't call it a line, because it extends through the bottom of there, we know that those degrees have to add up to 180. So we can use that to use this random piece of information they gave us about these two angles here. If angle Z and angle W are congruent, and I know that these angles over here make a linear pair, I can use that congruence theorem that we used the other day. So I know that angle YZX and angle YZW are supplementary. And that's because of the linear pair theorem. They make a line. And I know the same thing about the ones on the other side. So angle YWZ and angle YWV are supplementary too. For the same reason, linear pair theorem. And then because of that, I know that angle YZX has to be congruent to angle YWV because of the congruent supplements theorem. So I just proved that these angles here are congruent. So now when we look at the two triangles that we're trying to prove are congruent, I have an angle, and a side. And I can now say that triangle XYZ is congruent to triangle VYW because of angle, side. So that's it. You should be able to apply angle, side, angle, side, and hypotenuse length to solve problems and to prove triangles are congruent. So write down any questions you have and we can go over them tomorrow in class. Have a good night.